for ba bang gore ba kgone catch up. Okay, cool. Yeah. So I share, just share my screen. I don't know which one. Yeah. Okay, cool. So, yeah. So before we can go through, hey, let me close this up. Yeah. So before we can look at the document that I sent through, I just want us to understand a couple of things. So yesterday we installed Python, VS Code, and Git. So yeah. So on your machines, if you can follow along and just try to do what I'm doing here. So you can type. So don't type Python 3 because I have 2 versions of Python on my machine. So that's why I'm using Python 3. I have Python 2 and Python 3. So on your guys' machine, you only have Python 3, so you can just type Python. So that should work for you guys. So Python is a higher level programming, right? Which means that so I don't know if any of you know this, but when how computers work, right? There's an underlying language that the computer uses, like there's bytecode, there's machine code, and most people don't understand that, right? So Python, like other higher level languages, they provide you with a syntax that's much easier to understand for us. So meaning when you're looking at Python code and when you're looking at the same kind of code, which is machine code, they'll look totally different while you'll understand the Python code and not understand the machine code. So the computer does not actually understand Python. It understands bytecode, machine code, right? So Python gives us the ability to communicate with the computer via the interpreter, which is so you guys can see my screen, right?
Yes.
Yeah. So if we look at this here, where we talk about the Python interpreter, so this is we'll get to understand this more as we go through. But so here, what this represents here, this would represent your Python code that you write, right? And then what we installed yesterday when we installed Python, we actually installed the Python interpreter onto our machine, so giving us the ability to write Python code. So what happens when you write your code? So you write your code here, and then when you want to execute your code, you call the Python interpreter to try and compile your code, right? And that magic happens in here. And then the result of that is some kind of output that is run by your computer. So it interprets the code into bytecode, and the computer understands, and then it executes those commands on the low level. So that's why Python is called a high level programming language, but machine code or bytecode is low level because it speaks directly to your computer, like the hardware of your computer. So that's the difference between a low level language and a high level language. So a high level language is normally languages where us as normal humans, that's the one that we mostly understand. And so other programming languages like JavaScript, your Java, and them are also high-level languages, but there's a degree of how high. So most people, that's why I'm starting off with Python, because Python is I would say a much easier language to start off with than other languages. So yeah, let me just close this here. Come on. Okay, cool. I'm just gonna minimize this. Okay, cool. So by typing in Python 3 here, you guys on your side will type in Python. So I've opened the interpreter here, meaning I can actually start writing Python code. So one thing that I can do, I can actually just start adding numbers. So I just go 1 + 1, and then the interpreter knows, okay, 1 + 1 is a valid thing in Python, so it executes that and it gives me the value right away, right? So I can go 2 divided by 2, and then it gives me 1.0. So we'll talk about why that's the case later. So this is just how you divide numbers in Python. So one other thing, so I can go 2 times 2, which is 4. So you can do arithmetic operations in your Python code, and the Python interpreter understands that. So yeah, I don't know. Maybe I should go through the kinds of structures that we have. Are you guys following along, taking notes, or on your side? So I don't know what you guys are doing now. Just give me feedback when you can, or if I'm going too fast.
We are fine. We're following you.
Okay.
We're following you.
Following you.
So yeah, so they like most things, there's most high-level things, there are smaller building blocks that make up the whole thing, right? So Python is made up of amongst others a lot of data structures. Sorry. So the data structures being, you have your integers, which is what I was showing you now, which are your numbers, not all of the numbers, but there's integers, and then there's floats, which is also a number. So a float is a number that's represented as a decimal. So like when you go 2.5, this is called a floating point number. So which in short, we just call it a float. But a 2, when I just type in a 2, that's an integer. So both of these are numbers, but they are different kinds of numbers. So you have your integers, you have your floating points, right? And then you have this is
Yeah. Mute. Oh, sorry.
Yeah. So yeah, so now that we can, that means in our Python code we are able to represent numbers in two forms, as an integer, which is a whole number, or as a number with decimal points, which are called floating point numbers. So, and then there's strings. So a string is a sequence of characters, so which is represented in two ways in Python. So it's represented using your single quotes. So you have your single. So you have your single quotes. So if I have a single quote there, and I can write something there like letters, right? So there. So you see that this is called a string, and in your string you have your your sequence of characters. So your characters in here, you could see you have your H, your E, your two L's, your O, and a space, a W. So yeah, so all the single characters in your string represent your string as a whole. So yeah, like I said, it's represented in two ways. So I use the single quotes. So you can also use the double quotes. So whichever one you prefer, you can use. So if you look at this, the interpreter gave us, it's not the same thing, but it gave us single quotes as an output, even though I used double quotes for this one and single quote for this one. So that means the interpreter sees those two things as the same thing, right? So still following along? Yeah. So yeah. So I'll send the notes for this. I don't know, later today or early tomorrow, so that you guys can have a look at them again. So yeah, so we spoke about integers, we spoke about floats, we spoke about strings, which are floats and integers are just numbers. And then you have strings, which is a sequence of characters, being your letters and being your letters and other things. So actually, let me ask a question here. So what is the type for this thing that I just typed here?
It's a string.
Why? Wait, before you answer that, does everyone agree?
My quick question before I agree. Characters, do they comprise of numbers and letters?
Well, that's the answer. me answering that gives you the answer. So
okay. Okay. All right. Then okay. Then give us the answer so that I can know what's what.
so just because I have numbers does not make it a number, right? So if I'm saying whenever I say, okay, I put something in quotes, whether single quotes or double quotes, I'm saying that thing is a string. Whether I'm going to have numbers in there, I'm going to have special characters like asterisks and all of that. As long as I cover those things inside single quotes or double quotes, that's a string. So yeah, so that's a string. Jack is right. That's a string. Yeah. So the next data type is lists. So your lists. So we'll go through these data types more. Now I'm just giving you a high level overview of things to expect. But we'll go through numbers. We'll go through strings. We'll go through lists and other things in detail as we move on. Now I'm just showing you the building blocks of the language. So we have lists which are represented as so you use your. I'm gonna do this. I just want to get out of this so that I can take it back to the top. Yeah. So we have your lists which are represented by your square brackets. So if I have 1, 2 in there, so that represents a list. So a list is a sequence. So a string is a sequence of characters, right? A list is a sequence of other data types. So you can have inside your list, you can have your number, you can have your float, you can have your string. You don't even have to, like, I can say 1 here and then I can go hello there, right? There. So I have 1 and hello. So in my list, I have 1 and then I have hello which is a string. So a number and a string in a list, that is allowed. So you can have, if you want to, you can have your list being things of the same data type, which is you maybe just want to have a list of strings, you can do that. If you want to mix them up, you can also do that. That is allowed. So yeah, so practically any data type that you can have in the language, you can put in your list. So ask the question, is a list synonymous with an array? Yes and no. So some languages treat them as the same. Some languages don't, but the functionality is 99% the same. So in terms of how things are optimized and in the background, it makes them different. But some languages, it's the same thing. So like in JavaScript, a list and an array are the same thing, but in Java they're not. So that's what I'm saying. Yes and no. So depending on what language you're using, yes. So in Python, yes.
What's an array?
Array, that's what I'm saying. It depends on the language that you're using, right? So it is essentially a list.
Okay.
So, but in the background, languages do optimizations differently, so which makes them different. So in some cases, you find that a list is more beneficial than an array, but in Python, they're the same. Yeah. So so we spoke about lists. So we have another data type that we have is dictionaries. So dictionaries are represented with by rather curly braces or curly brackets. So you have your curly brackets, and then inside your curly brackets you have key value pairs, meaning like I would say I would have something like a name, and then that name needs to be mapped to something. So I would go name and I'll go Mike. So this represents a dictionary. So what this means is saying the key here is name, and the value of that name there is Mike, right? So we'll get to understand these as we move forward. And your keys and your values can be anything. So you can have your value being a number, a string, a list, another dictionary, yeah. But your keys are numbers and strings, nothing else. Yeah, so this is called dictionaries. So
wait, level.
Yeah.
Name and Mike, which one is the key?
Name is the key, and then Mike is the value. So your key and your value are separated by the colon there.
Okay.
So on the left side of your colon you have your key. On the right side of your colon you have your value.
And then you say the key can be any of the data types.
No, the value can be any of the data types. The
Okay,
key is a string or a number.
Okay.
Yeah. And then so we have another thing which is similar to a list, but they're not the same. So one thing that I did not mention about a list is a list is mutable, meaning you can change the contents of your list as you please. So we'll learn about that at a later stage, but you can say, okay, I don't want one to be there anymore. I want it to be a 2, and you can do that. You can say, okay, I want to change hello from being hello to being world, and you're allowed to do that. But there's another data type which is similar to a list, but it is not mutable, it's immutable. So meaning you can't change the contents of that data type. I'll tell you about it now. Once you have created it. So that's called a tuple. So which is represented by, so it's instead of square brackets, you have your round brackets. So I can go 1, hello, and then I close that. So that's a tuple. So if you can see, the contents of these two things are the same, but the difference is I cannot. So I can go here and say, okay, change this one into a 2, but I cannot come here and say change this one into a 2, because after you've created your tuple, you cannot change it. So if you want things to stay in that state, then you create a tuple. But if not, then you can use it as a list. So yeah. So, and one other thing, these three, so your list, your tuples and your strings, that they have something in common, which is order. So they are ordered, meaning you can access you can access the entries in your like for your string, you can access the characters in your string in the order that in the order that you see them in. So like you can go to your string and say, okay, this hello over here, I want to access H because I know H is at this particular position. You're allowed to do that. So, but the order, there's ordering for lists, strings, and tuples. You have order, but for your dictionary, there's no order. So yes, you can access your entries inside your dictionary, but there is no order in how you access those things. And then, so yeah, so another one that doesn't have order is a set, which looks similar to your dictionary or your list, which in different ways. So it's similar to a dictionary because they both use Kelly brackets, but your set is not what your set does not have key value pairs. So like, let me show you this. So your set, nope, shit. Okay, I'm gonna have to that 1, 2, 3, 4. So yeah, so you have that. So it looks like a list, but you use your Kelly brackets instead of your square bracket. So, and one thing that's special about sets is sets have unique entries, meaning like if I was to, in a list, I can do something like this, right? I can have 1, 1, 1, 1, and that's allowed, and it's fine. But in a set, if I go 1, 1, 1, and then close that up, it sends me just 1, right? Because those things are repeated, and the set is saying, okay, I don't allow duplicates in my set, meaning I'm not going to allow 1 3 times. So the final result for this thing is understood as just 1. So it has one thing in the set. So that's sets. So also sets don't have order. Yeah, sets don't have order. So yeah, the final data type that we're going to be looking at is they're called booleans. So booleans are your true and your false. So in Python, it represents, if I just go true, and then it understands that. So, and then if I go false, it understands that. So we will learn how to use those two, like your trues and your false, later when we execute some statements in our code. I don't know if you guys have questions or not.
Yo, please, can you?
I'm fine. I think a lot will be clear as we go on.
Yeah.
Can
Yo.
you go
I
over
believe
the-
this is like the building blocks of it, right?
Yeah. So Cree, what do you say?
Can you run through the, like, explain the dictionary?
Oh, so for now, I think let's not look. Let's try not to go into too much detail, right? So because we will go through dictionaries as a whole in detail, right? So now I was just showing you the high-level representation of the data types that we have. So
Yeah, just exactly what you said. Just please run through it quickly again. Don't have to go any deeper.
Okay. So your dictionary, right? So the syntax in the language is you have So you surround the contents of it with your curly brackets, right? And each entry in the dictionary is represented by your key and your value. Your key and your value are separated by a colon. So like here, if I'm looking at this dictionary, I can say, okay, the key for this entry here is name, right? And the value is Mike. So I'm just gonna quit out of this again, and then clear that up. Open that, and then I'll do that again. So I'll just go name Mike, and then right. I'll just, can I do that? Oh no, yeah. So I'm gonna do another one here. Name Mike. Mike. So you guys can understand more. Whatever. Right. So yeah. So looking at this dictionary that I just wrote here. So each entry in a dictionary is separated by a comma, like you saw for the list and your tuples, right? And your sets. But the difference is in your dictionary, your entries are key value pairs. So meaning at this here, we have our key value pairs. The key is name and the value is Mike. So for your values, you can have any data type. So you can have name being a number, like name, the value for name being a number, a string, a list, a dictionary again, or a float, and you get that. So that's how. But if I was to ask how many entries do we have in this dictionary over here, what would you say?
Two, nigga.
Yeah. So so we have 2 entries in here. So you have your name and your surname, right? And those entries have values Mike and Ted. You see that? So I don't know if that clarifies what you were asking.
Yeah. That's dope. Now I get it now.
Okay, cool. So yeah. So as you can see, I was able to write my code in just I typed Python 3, open the interpreter, and then I just started communicating with it, right? Because the things that I was typing here are valid Python statements, right? So it allows me to do that. But as you build bigger programs and all of that, you don't want to write your Python your code in here, because as soon as you quit out, you've lost the code that you just wrote, right? So the way that we do this is we make files for that. No folder opened, whatever. Right? So we make, what's going on here? Did I not open this thing here?
Wait, level.
Yeah.
So the initial one where you start writing Python is like you're just communicating with the computer only.
So you are communicating with the interpreter directly. So you open the interpreter and then you're just sending commands and it's executing them as you type them in, right? So
okay.
Yeah. So but that's like I said, as soon as you get out of the interpreter, you lose the code that you just wrote. So for you to be able to write programs and bigger programs, you need to put those things into their own files. And so Python, like a Python file. So a Python file has, I'm not sure if you guys went through the document that I sent on the Slack channel. So a Python file is represented by a .py extension. So if I'm just going to create, so I'm not sure how many of you are familiar with VS Code, but so if you look at this things here, so this one here, I can actually just use that to create a folder, right? I can use that one there to create a file. And then, yeah, this one is to refresh the structure over here. That one, actually, it collapses files when you've opened them, or folders rather. So I'm going to create a folder here. I'm just going to call it started. This is where, then I can click on this started over here, and then click on that, and then I'm going to, it allows me to create a file. So if I go intro.py, which specifies that, okay, this is actually a Python file, right? So that I can be able to write my Python code in there. Just give me a moment. Yeah. So meaning the same things that I was writing in the Python interpreter when I open it here, I can actually type them here, right? I can go like I typed 1 + 1, right? And then that is valid Python code, right? Now, how do you execute that code? How do you run the code that you just wrote in your file? Because when you were writing the very same thing in your file, I'm just gonna interpreter, when I did 1 + 1, it immediately gave me 2 + 2, right? I mean 2. It immediately gave me 2, right? So how do we get the same behavior for the things that we write in our files, right? So I have 1 + 1 in there. So in order for me, actually, I'm gonna move this file to the top here. Just so, yeah, just gonna move that file to the top. So for me to be able to execute the contents of this file, I need to go, I can go Python. So I'm using Python 3. We're using Python 3 for this, but on your guys' side, it's just going to be Python. So, and then I can specify the name of the file. So before, when I just typed in Python 3, it opened the interpreter. But now, so you can use the interpreter in different ways to be able to do different things. When I specify Python 3 and then I specify a file name, so this is my file here. My file is intro.py. So what that does is say, okay, instead of opening the interpreter, take the code, take the contents of this code, and then put them in the interpreter and give me the output, right? So if I press enter here, what would you expect?
Two.
Okay.
Like 2, I think.
So yes, yes, it is 2. but when I run that, it doesn't say 2, right? So when I run that, it doesn't say 2, because it's, so what the interpreter does is say, okay, it's going to look at the first line in the code, right? And say, okay, it adds them up and it gets a 2, but it actually doesn't send them back to you for you to see it, because it's, if you are running this thing in your interpreter, yes, the evaluation of that statement, so this is called a statement. The evaluation of that statement results in 2, but actually it doesn't show it to you, right? So to be able to see the execution of that, you need to use other special functions, or yeah, special function that's that comes with Python, built into Python, called print. So if you want to explicitly see the result for this, so you can just go print. So you're printing 1 + 2, and then that's how you're telling the interpreter, okay, show me the result of this statement over here. So then it's going to execute this, it's going to give it 2, and then it's going to send it back to your screen now. So if I do that, now I'll get 2, right? So, and your print, this is, so it's called, let me, your print is, this is called, it's a print function. So, and how you treat functions in Python is you have to call your functions, right? So just stop me if I'm going too fast. So if I just type print like that, right, nothing happens, right? Because yes, print is a function, but for me to be able to execute that function or run that function, I need to call it, right? And how I call functions in Python, I give them round brackets like that, right? And different functions have different behavior. So, but your print function allows you to print something to screen. So any data type is allowed. So you can print your number, you can print your array, you can print your strings, you can print a dictionary, your set, and then it will just print that out to you. So now if I just go print 1, it will show me 1 on the screen, right? And then if I go print 2, show me 2 on the screen. If I go print 2 over 4, it'll print 0.5. So, and I'm allowed to have multiple, so I can have as many as I want, right? So I can do those. And then if I run the program, I get 0.5, like 5 times, right? And yeah, so I just ran that. So that's how you run your program. So this file over here called intro.py is your program, and you're just feeding the contents of this of this file to your interpreter, and it's sending it back to it's executing the contents of that and gives you a result. So your result will not always be printing to the screen. So your results can be a lot of different things. Like maybe you want to send an email to someone, or you want to send an SMS to someone, or so you can be able to do those things as you move forward. So yeah, maybe just run your program, send email and give it a particular email and a message, and then it sends that through, right? You can maybe open your browser within your Python code, or you can interact with a particular website as if it was you, right? So you can give those instructions as you learn more. So yeah, I don't know if there are any questions.
Yes, let's start with the folder that you have there that's written started.
Yeah.
Is that a folder that you save on the computer, or you open that folder using the VS Visual?
So I created that folder within this. Hey, can you put earphones on, bro?
Have you?
So you can create your folder here. So if you look at on the panel on the left side of your VS Code, you have the first one which creates a file, and then you have a second one which creates a folder. So I can actually create a folder here and just call it, right? So nope, created that file inside, a folder inside. So yeah, so so yeah.
Remember, let me see. I'm trying to figure out.
Now empty like this.
Still says
nothing.
Open folder.
Sorry?
That thing just says open folder for now. So when I click the open folder, it takes me to the Mac, what is it? Windows.
Oh, I
file.
See. So let's do this, right? Let's say you have a folder on your desktop, right? I'm going to create a folder, and then I'm going to call it class, right? And then so you can actually, so where you want your programs to be, right? That's where you can create that folder on your computer, and if you want to. But if you already have a folder, you can just go there, actually drag it to your VS Code if it's at the bottom of your what do you call it? Yeah, taskbar. So you can just drag. I can just drag this folder to my VS Code, right? Just go there, take it to VS Code, and it'll open that folder in VS Code. So like if you see now, it says class. That's the name of the folder that I'm in. And if you toggle your terminal there, you see it says desktop and then class. So it shows you where that particular folder is. So I can actually create. So now if I create another folder in here, right? inside my VS
Oh.
Code. And then if I go
Okay,
back
now-
to my desktop and open that folder is there. You see that?
Okay, I see it now. I see
Yeah.
it.
Same thing if I create a file and go, no, I'm creating that file inside. I want to create it outside that. And go intro.py. And then if I open that, I have my intro.py over there. So yeah. So you can just drag your folder, the folder where you want to work, in. So call that your workspace, and then just drag it to VS Code, and it will open VS Code inside that particular folder. And then I think you can also, depending on whether you clicked on all of those settings when you're installing VS Code, you can right click on your folder and then open. You'll see some option that says open with VS Code, I think.
Okay, Level, wait. There's something I want to ask.
Yeah.
I did the folder. I did the file the way you did it now. Then it opened properly. Then now there's a notification that came that says that the Python extension is recommended for this file type. Install show recommendations. I don't know if
I
Oh.
got the same one. I got the same thing too.
Yeah. Okay. So yeah, just allow it. Install them. It gives you an install option, right?
recommendations
Yes.
and install.
Yeah.
Yeah,
So
recommendations and install.
yeah, just install. Just click on the
Okay.
install there so that it
Okay.
installs it. Yeah. So yeah, everyone
Okay.
just do that. Okay. So I will. So yeah, you can. I think now with the document that I sent to you guys should now make sense. I'll send another one on the data types. So either tonight or tomorrow morning. Yeah. We good?
Yep, we good.
Is it Fidel?
Yeah, I think it's good deal. Yeah, so if you have any other questions while you're working at home or looking at something at home, just post it in the group. What do you say?
I almost thought or homework Ashion. This is what you must do.
No, just the homework is to read through the document and understand it.
Okay.
Yeah. All right. Yeah. Sharp.
Wait.
Yeah.
No. Ah, okay, no, I'm fine.
Okay.
It's fine.
Cool.
Level what we were installing earlier to the extension one. If you do installer and then it brings up, my computer brings up another pop-up screen. It says linter pylint is not installed. Do I need that?
You don't need it, but you can install it. It's fine.
Okay.
Yeah.
Okay then.
Cool. All right, man. Sharp.
Alrighty, bye. Thank you.
Hey.